Hi everybody. Today we're going to be graphing sinusoidal functions, so continuing what we were doing in the previous lesson, except today we're going to apply all the transformations. So before we get into that, let's review some key information that we want to know. The first thing I want to review is converting between radians and degrees, right? Converting, there we go. All right, so most of the work we do with sinusoidal functions in most cases is really in radians. Although your textbook might use degrees and some of your teachers might use degrees, as you move, for those of you who are continuing in your math studies, it's generally always in radians. So we want to start getting comfortable with that. Now, I'm not going to be pushing super hard. Instead of stressing you out, let's just talk about how you can convert. So if you're having trouble converting, we can do that. So like, for example, let's look at this thing here. It says, let's start by graphing the sine and cos functions. We're going to start by reviewing how to graph those, right, that we learned. And it says, for the domain of between 0 and 2 pi. So we want our x values between 0 and 2 pi. So you might say, well, I don't remember what 2 pi is, right? Or I don't remember whatever any radian measure is. To convert to radians, all you have to do is multiply by 180 divided by pi. Okay, so if I have 2 pi and I want to convert that to radians, right? Well, what's 2 pi times 180 divided by pi, right? So obviously the pi's cancel out. There we go. And what's 2 times 180? You end up getting 360. Oh, okay, so 2 pi is 360 degrees, right? Our full circle. So if you're stuck, like the graphs that I'm using, notice how I have radians on all of these. You can just convert them to degrees if that helps you out as you transition into learning more about radians, okay? All right. So when we say we want it between 0 and 2 pi, it's like saying we want our x values between 0 and 360 degrees, which is a full circle, right? So as we go around our circle, we start at 0, right? We go all the way around to 2 pi. Or another way of saying start 0 degrees, right? And we go all the way around to 360 degrees, right? If I'm just kind of looking at the two different ways of writing it, the radian measure versus the degree. All right, so let's see here. So if you look here, the scale on this graph that we started using last week, it says, let's use a scale of pi over 6. You'll notice each of these squares that I'm using for my graphs each time are going to be pi over 6. Okay, so that's what each of these are. So again, if you're saying, well, how far is pi over 6? What is that? I forget. I don't have my unit circle. You can look it up on a unit circle, or you can just convert. So let's times that by 180 over pi, right? All right, so when we do that, what do we get, right? Well, obviously the pi's cancel out. So this is something you really want to know because you want to get comfortable working with degrees, right? Or with radians and degrees. And then what's 180 divided by 6, which is 30 degrees. All right. So in other words, my scale, every square is going to be worth 30 degrees. That's what I'm counting by, 30s, right? So if we look here, I'm not going to write it in every time, but this would be 30, 60, pi over 2 would be 90. So I'll just write in the degrees. And if it helps, feel free to write them in. You don't, don't be embarrassed. Write it in. It helps. We want to get better at this, and part of getting better is to, write this stuff down. So then, 120, 150, pi would be 180 because that's half a circle, right? And then so on and so forth. 180, 210, 240, 270, and then keep going all the way till we get to, 270, that looks like 270, and then 360, right? That would be a full circle. So same thing when I'm looking at my unit circle. Remember our unit circle from a while ago? This is 90 degrees, right? That's a 90 degree angle up there. Well, if I want to write that in radians, what is that? That's pi over 2, right? Same thing as I go around. Pi is a full circle, right? Or sorry, half circle. And what would that be in degrees? 180 degrees, right? And so on and so forth. And this would be 3 pi over 2, right? And then that would be 270 degrees. And then back to our 360 or 2 pi. So remember, a radian is the length measured around the outside of a circle that has a unit, a radius of 1, right? And 360 is if we measure rotation around that, okay? All right, so let's start by graphing the sine function. Now, the one thing I want to point out again is you notice how I have here y equals sine x, right? Depending on what book you're using, or textbook or handout or whatever, sometimes people like to use x and sometimes people like to use theta instead. They use that Greek letter, like to use Greek letters for angles. It really doesn't matter. X, theta, whatever. So if you write theta, like look on my graph here, I have theta here, right? But look at what I wrote over here is x. Now, I should be consistent. Of course, we want to be consistent. I'm just kind of going back and forth between the two, trying to get you used to the fact that it could be either or, okay? It's just a symbol we're using to denote the x coordinates. So I like to use x more than theta, but I might be in the minority here. All right. All right, but I know when I got in university, we use x more than theta. So I think theta is just more popular with degrees and the idea of angles, right? Where x is more consistent with our regular graphing. Okay, so I got theta here, or I can just write x there, okay, our x coordinates. So let's talk about sine, right? Let's start with this guy right here, the graph of sine of x or sine of theta. So now, remember from our unit circle again, as we go around, let's just look at these 4 key points. This one, this one, this one, and this one. And let's just focus, don't worry about the x coordinate. Let's just think about what the y coordinate would be, because the y coordinate on the unit circle is the definition of sine. That's what sine is, right? So you start here at 0, then you go up to 1, then you come back down to 0, then you go to -1, and then you're back to 0 again. Now that's when we're looking at both sine and cos on the unit circle. But what we're doing when we're graphing these sinusoidal functions is we're breaking it up and we're only looking at one or the other. So in this case, we're just looking at sine. And we're going to make the x coordinates, instead of cos, the x coordinates become our radian or degree measures as we go around. So what do I mean by that? Well, let's write it in degrees first. Maybe we're more comfortable with that. So let's say like starting at 0 degrees on my circle, and then going to 90 degrees, right? And then going to 180 degrees. So I remember I told you this is a really important table to get used to, right? And really learn, okay? And then 360 degrees. So there's one full cycle around a circle, right? From 0 to 360. Now, again, we want to get comfortable with the radians. We want to get more and more comfortable with these. So don't shy away from them. Those are going to, continue in math. You really want to, okay, in physics and science and all that. So 0, and then we go to pi over 2, which is a quarter of a circle, and then 2 pi over 2, which reduces to just pi, and then 3 pi over 2, which is 3/4 of a circle, and then 4 pi over 2, which reduces to 2 pi. Sorry, it's a little sloppy there. But again, do you like to write it in radians, or do you like to write in degrees? Obviously, you're probably more comfortable with degrees at this point. The more you do it, the more comfortable you get with the radians, right? So now, what is the y value when we're at 0, right? Let's highlight these, right? When we're at 0 degrees, 90 degrees, 180 degrees, 270 degrees, and then back at 0. So if I write these in here, I get 0, 1, 0, -1, 0. So you really want to know this table really well if those of you go into grade 12 math, okay? Now let's set up a scale. Now you can just make the scale 1 like this, but it's going to be really squishy. So I'm going to make my y scale just a little bit bigger so I can stretch this out. So I'm just going to make 1 here and -1 down here. Because for our starting graph, right, the range, the highest it goes is 1, the lowest it goes is -1. So just so I can get a better picture of what it looks like, I'm going to extend my scale a little bit. So we start at 0, then at 90 degrees or pi over 2 we're at 1. Then at pi, we're back to 0. Then at 3 pi over 2 or 270 degrees, we're down at 0. And then back to 2 pi. So this is the graph. I mentioned it a lot last week. This is the graph you want to get really comfortable with. And when we're doing our transformations, we got to first identify, are we working with sine or cos? If we're working with sine, this is the table, okay? So when I start these questions off and I start doing them, I'm not going to go through the table again and again. I'm just going to start with this table, okay? And that's what I'm talking about. Now, the next thing it says it wants us to extend this, right? So now, this question says extend the graph for the domain, so our x values, between -2 pi and +4 pi. So we want this to go longer. So what I like to do is I always like to draw in a vertical line at my cutoff points, right? So I don't go over them. So it wants me to go from 4 pi and the positives all the way to -2 pi and the negatives. Now, why is that? I just chose those numbers. That's not like every time we have to do it. What we drew already on the graph is one cycle of sine, right? The standard starting cycle of sine. I'm extending it now to go farther. I could go as far as I want or whatnot. So again, I'm going between -2 pi, right, which would be -360 degrees, all the way to +4 pi, which is 2 full circles, right? If 2 pi is 1 circle, 4 pi is 2 circles, right? So that would be 720 degrees. So again, if you want to write those in, go for it, right? So what did we write here? I'm lost already. There we go, 4 pi. So again, 4 pi right here would be 720 degrees, right? Now, to continue drawing this, I'm going to do it in a different color here, but all you do is keep the pattern up. Like, what do we do? Remember, it's a periodic function. It repeats the pattern, okay? It has a period that it repeats. So it goes 0, right? 0, 1, 0, -1, 0. And then we just repeat. So let's do the next part of it. We're at 0. We go back to 1. We go back to 0. We go back to -1. Oops, I think I'm missing my mark here. There we go. And then back to 0. So I can continue it like that, right? So sine, they call it a sine wave, has this smooth wave pattern when we draw it, right? We don't want to be doing this. That's the other thing I got to mention. A lot of people, I was looking at some of your work, it's like this, right? It's not lines. You have to really try to work for that smooth wave there, okay? Now let's go in reverse, right? Let's back this up. So if I'm going like 0, -1, 0, 1, 0, I'm going to go backwards to -1, 0, 1. There we go, back to 0. Okay. So there is sine, pretty good, not the best, but there we go, extended all the way from -2 pi to 4 pi. And it can keep going forever, right? It's a periodic function. It doesn't end. It just keeps going in both directions forever and ever, and it creates that wave pattern, okay? All right, let's move on and just draw cos really quickly, and I'll do it a little quicker than this. Again, big thing, remember, if you're getting lost at any point and you're like, what number is he talking about? Convert it to degrees to help yourself out, okay? So I talk a lot about in radians, but if you get stumped, and I was lost on this a lot when I was your age, because we just kind of had it thrown at us, and I had no idea about this radians and how to convert it. I just kind of was drowning in it. Hopefully this helps, right? Convert it. It's how you're going to learn this stuff, right? Convert it by timesing by 180 over pi, reduce it, and what do you get in degrees? All right, so let's check out cos now. Okay, so let's check out cos real quick. I know we've done it before, but it's really important I go through all this before I start graphing all the transformations. So again, we're going to be using 0 degrees, 90 degrees, 180, 270, and 360. These are the common starting points. Or in radians, 0, I better put my degree symbol. We always put the little circle to indicate that it's a degree measurement. Radians, we don't, because radians are just a true regular number, right? We're just measuring around the length around the outside, okay? Degrees are out of 360, right? All right, so 0, pi over 2, which is a quarter of a circle, 2 pi over 2, which reduces to pi, 3 pi over 2, which we can't reduce, and then 4 pi over 2, right? Which is just 2 pi, a full circle. Okay, so I've written both there just so we can compare. All right, now the y-coordinate here, this is where people get a little mixed up, because on our unit circle, right, cos, right, right, when we talk about our unit circle, remember cos of that angle, or cos of x, and sine of that angle, right, that gives us the x and y coordinate. So cos is the x coordinate. So, cos starts at 0. Oops, sorry. Cos doesn't start at 0. I'm thinking the sine. Cos starts at 1. We're over here at 1, the x coordinate, right? Then to 0, then to -1, then to 0, and then back to 1. So when I fill in cos over here, it starts at 1, 0, -1, 0, 1. There we go. All right, so remember what we're doing over here now is we're making the x coordinate represents our radian or degree measure as we go around the circle, and we're only looking at the cos. We're not looking at the sine, right? So we're picking apart this unit circle, and we're choosing to only look at one function or the other. And that's definitely where some confusion comes in. So if I remember finding that a little confusing at first too. All right, so let's graph this thing. So again, I'm gonna put some. Now again, if we're lost, remember there's 0, right? And I've just made every one of these 30 degrees or pi over 6, right? That's the scale I like to use a lot. So this would be 90 because it's 3 times 30 degrees, right? Pi is 180. 3 pi over 2 is 270, and 360. And you can write them all in if you want. Okay. Getting used to it. The better you get at it, you don't have to have it all perfectly memorized, but the better and more comfortable you get with going between these measurements, the better you'll be. And I'm just going to make my scale a little bit higher. I'm going to make this 1 and -1 again. Okay, so let's graph this thing. So when we're at 0, cos doesn't start at 0, it starts at 1, right? And then it comes down to 0, then down to -1, then back up to 0, and then back up to 1. Now when we draw it, don't draw a V. I know it's tempting to just go, that's good enough. You really have to strive to try to make that smooth wave. And the sine one kind of starts out a little easier. The cos one is a little more confusing. You got to kind of imagine a half a wave there, right? And then this bottom wave, that's not the best, but there we go. And there we go again. All right, so there's one cycle or one period of cos. I should have labeled that on the other one. I meant to write that this is one cycle, one period, right? One cycle, right? And the period, if someone says, well, what's the period for a sinusoidal function? The beginning starting period is 2 pi, or 360 degrees. Okay, that's what it takes to finish one trip around a circle, right? All right, so now let's extend this again like I was doing in the previous one. Let's extend it all the way to 4 pi on the positive side and -2 pi on the negative side. And again, I've just kind of chosen that as our limits here, so we can get used to the idea that we're not always going to be drawing this between 0 and 360. We want to extend it a lot. So here's x equals negative 2 pi, and here's x equals 4 pi. So remember, if I was to write this in radians, this would be, or in degrees, this would be x equals negative 360 degrees, and this would be x equals 720 degrees. Okay? All right, so let's extend it. Let's just keep the pattern going, right? 1, 0, negative 1, 0, 1. And then we come back down to 0, and then back down to negative 1, and then back to 0, and then back to 1. Now, once you start drawing the rest of cos, you might start realizing, I know we've talked about this before, that sine and cos are the exact same wave. I'm just going to extend in the negatives here while I talk. They're the exact same wave. They're identical, but for one and only one difference, where they start. Okay, because it's basically just shifted. Cos and sine are the same thing but shifted. So I'm just going to highlight where we could start sine. Like, look, doesn't sine start at 0? Like, look, there's sine that I'm highlighting right there. So you could say, oh, sine and cos, it's just shifted back. Look, I just shifted it back. If I took this graph and moved it, I know it's hard to kind of draw this, but what if I move this right to here, right? Then it would just be sine. So they're really the same graph because the numbers we get from the unit circle are the same. It's just depending if we're looking at the x or y coordinates. So they're really the same graph, except cos is just sine shifted back 90 degrees, right? That's it. It's just been moved back negative pi over 2, which is 90 degrees. That's it. So they're really the same thing. But we want to know the starting table. That's starting. When you only look at that first group, they sure look a bit different, right? Okay, so we want to know that. There's our basics. There's my two tables. So every graph I encounter, I'm going to start with either sine or cos, and these are the two tables I'm going to start with. Okay, let's go through our transformations now. Okay, so let's talk about our transformations. The good news, it's the same 4 transformations that we've talked about all year. It's the same 4 transformations on any two-dimensional function, right? So first thing to remind you again is sometimes we write x, or sometimes you might see the symbol theta instead of x. Same thing, right? So same with here after my transformation, right? All right, now I've only written it for sine, but we could write the same thing and say y equals cos of x or cos of theta, and same thing over here, instead of sine, write cos. It just depends on which one we're talking about and which table we start with. I'm just using sine for now. So it's the same 4 transformations, a, k, d, and c. All right, so why don't we start with a? That's the one we've already covered. Let's review both the ones we've already covered. So a, remember how we multiply our y coordinates by a, and what does that cause? I'm just gonna write the short forms here, a vertical stretch, right? And if it's negative, right, if a is less than 0, then there is a reflection in the x-axis, or you can call it a vertical reflection, right? So if it were to open, if it looked like this, right, well, after we reflect it, it's going to look like this, okay? And the a part causes a stretch. Okay, so there we go. That's the first thing. And we want to talk about the a affects the amplitude. Amplitude is the absolute value of a. So if a is negative, we ignore it when we're talking about the amplitude. So if a was negative 2, your amplitude would just be 2. And what do we mean by amplitude again? The amplitude is that vertical distance. Let's just draw the sine function really quick, right? The vertical distance between your middle, your axis, to the top, or to the bottom, all right? So it's a measurement of length. That's why we don't include the negative, right? Because lengths we don't say are negative. That's the only reason we're getting rid of the negative, okay? So it starts out as 1, right? Because remember, our starting one is 1, but if a gets bigger, if it's 2, 3, 4, it gets stretched vertically, okay? And let's get the other one we've already talked about out of the way, which is c. C is what we add to our y coordinates. So we take what we already did with them, which is a times y, and we add c to them, right? And that causes a vertical translation, up or down, right? C units, okay? So that tells us how much we should be moving up or down. So you might see a lot of textbooks like to use the word vertical displacement instead of vertical translation, especially in physics class. I think vertical displacement is the common phrase, okay? But it's the same thing. So if a question, what I'm going to basically have you do when you're doing these is, instead of writing out these full definitions like I'm doing over here, you're just going to tell me the 4 things I have over here. So you're going to tell me what's the amplitude, and you're going to tell me what's the vertical displacement. So I'm going to kind of follow along with that. So in other words, all you have to say is the same thing. Your vertical displacement is up or down, okay, c units. So I'm kind of comparing what we've already learned here to maybe the more common way of expressing it with a sinusoidal function, okay? All right, so there's a, and C and what they do. They cause our vertical transformations, right? Stretching it and flipping it vertically with the amplitude, right? And our vertical displacement, moving it up or down. All right, so now let's talk about what we haven't talked about, at least with this. We've talked about it a lot this year, the K and the D. Okay, so let's start with K. So if you remember K from before, it's the same thing. Remember what we do is we multiply our X coordinates by 1 over K. So 1 over K times X. And it's the same thing, except it's a horizontal stretch, right? Or it can be a horizontal compression. All right, but we just generally say a horizontal stretch at this point. All right, so horizontally stretching, pulling things, right? Or compressing them this way, right? Either squishing them or compressing, where this one, stretch them vertically, right? Or squish them, compress them vertically. All right, and same thing. If K is a negative number, right, then we have a horizontal reflection, right? So things will reflect this way, right? So sometimes, there we go. So hang on. So let's just say this was our original, right? Now it keeps going forever, right? But the idea is it would reflect like this, right? It would be a mirror like that. Okay. Now, this is the first pretty important thing I want to talk about is the period. Okay, how do we determine our period? Remember, the period is how long does it take to do one cycle of this, right? So normally our period starts, I'm just going to draw a quick little sketch here again, right? And I'm just using sine every time as the example. Normally our period starts as 2 pi or 360 degrees, right? That's what it takes to do one cycle. But as we stretch it out or compress it, that's going to change. So there's a little formula to find your period, okay? So period is equal to, I'll just write PER a lot for period, okay? Now it depends if we're working with radians or degrees. It's 2 pi in radians divided by K, okay? Or if you prefer to use degrees, it's 360 divided by K, all right? So we take that, we divide, that'll tell us our new period. So when we do some examples, I'll show you what I mean. And the period comes in really helpful with some shortcuts to graphing this stuff, okay? And finally, let's talk about D. If you recall from our many transformations this year, right, we take what we did to the X coordinates, which is 1 over K times X, and then we just add D to them, right? So that is a horizontal translation, which means we're moving it to the left or right, right? Horizontal translation, left or right. And that's it, right? There we go. D units. Now, that goes with something called, in physics especially, they like to call it the phase shift, okay? It's just another way of saying exactly what we said, okay? So your phase shift, you can describe it the exact same way. You can just say you've made a horizontal translation. You can just say left or right, exact same thing. So question says, what's the phase shift? You can just say left or right, depending on which way it's moving, whether it's negative or positive, however many units, D units. Now, here's the thing, and I want you to take special note of this, okay? Because I want to show you some shortcuts to graphing these. And there's a lot of different ways of graphing this stuff. I'm trying to really get down to the essential main way that'll work for, you know, the key way to learn some important stuff. There are definite shortcuts, and a lot of teachers like to use shortcuts, and nothing against that, right? But there is one kind of key shortcut I really want to stick with here because it makes your life so much easier. All right, so this phase shift, this D, whatever it is, whatever that number is, okay, that's going to be the location of our first point. And that comes in really handy. This is the location of the first point we're going to graph. So if you know that, it makes things a lot easier. And there's some other shortcuts, and no problem if you want to use them, okay? But that's a key one. That one really makes life nice. Okay, so keep that in mind as I'm doing these, and I'll try and keep pointing that out to you as we go. Because when I do the tables, instead of doing every single value in every single table, we can shortcut this a lot and make it a lot neater and quicker and a little less confusing. All right, the other thing I just want to add, I'm just going to squeeze this in at the bottom, is don't forget the equation of the axis, because that's going to pop up. I forgot to include that in my notes here. Equation of the axis. That's the middle of our graph. And remember, it starts, we've seen this already, it starts at y equals 0, but it changes to y equals c, because remember, c tells us how much we move it up or down. So that middle of our graph, right, which is basically this guy right here, that middle of our graph, right, it's going to move up or down depending on what c is. Okay, so let's check it out. Let's do some examples. Okay, I'm going to walk through a few examples. And like I've been saying, it's the same transformations as before, so if you feel pretty comfortable with those, it shouldn't be a big departure from what we've done before. All right, so first, let's identify which function we're graphing. We're graphing sine, right? So I'm going to set up a table of points here. I already got it basically set up with, I've written both the radian measures here and the degrees. Like here's the degree measurements and here's the radian measurements. And it's good to have a good grasp of both. And I'll kind of walk through how you can do transformations on both, and you can kind of graph it as you see fit. Or at least, whatever you're most comfortable with and getting better with. Obviously, you're probably mostly comfortable with the degrees, but we want to get better at radians. Okay, so we're graphing sine. So let me come over here and let's write down y equals sine x or y equals sine theta. You can use theta or you can just use x, okay? All right, so what was our starting table for sine? And again, even if you forget, remember what you can do is you can punch these all into your calculator. Like what's sine of 0 degrees? What's sine of 90 degrees? What's sine of 180 degrees? And if you punch those in, it'll give you these values I'm going to type in. It goes 0, 1, 0, -1, and 0. All right, so there's our starting table, right? That's what we want to use. That's one cycle, one period, right? So remember, the period starts as 2 pi or 360, right? One circle. That's what it takes. So notice how we end at 2 pi. Okay, so let's start by identifying all the key important information like A, K, D, and C. All right, so let's start with A. Okay, so A is our, there we go, our vertical stretch, right? So in this case, A equals 2. So what I would do is I would multiply all my y coordinates by 2. 2 times y, right? So let's just do that right now. 2 times y, right? So 2 times 0 is 0. 2 times 1 is 2. 0, -2, and 0, right? So everything is twice as high and twice as low. Now again, we can kind of, once we graph this, we can talk about some shortcuts. So some people don't even like making the tables. They just like to kind of shortcut it, and they recognize, all right, well, that's going to be my amplitude, right? That's the distance from the middle to the top. So let's also identify our amplitude, right? Amplitude is the absolute value of A. So the absolute value of 2, well, in this case, it's just 2 because it's not negative, right? All right, so it's 2. So that's the distance from the middle to the top and the distance from the middle to the bottom, right? All right, let's talk about C right now while we're on it. So what is C? That's the number at the back here. C is equal to 1. All right, so that's going to be my vertical translation, or they like to call it the vertical displacement, how much we're going to move it up or down. So we're going to move it up 1. So we're going to take that 2 times y, and we're going to add 1 to it. So this is 1, 3, 1, -1, and 1. All right, so now I can, without even worrying about the x's yet, let me write that down here. So if someone says, all right, I want you to describe it, which I want you to do, just state that you're moving up, right, 1 unit. Okay, that'll do just fine. And the big thing that also tells us, so I'm just going to put kind of a little dash line here, because that tells us our axis in the middle, right? Our axis is y equals c, so it's going to be y equals 1. So I'm going to draw a vertical line at y equals 1. All right, so to do that, let's come up with a scale. I'm going to go every other square here just because I want to stretch it out. If you're someone who just wants to go 1 square as 1 unit, that's fine. I just like to kind of get a better view of it and stretch it out a little bit. So 1, 2, 3, 4. The highest we go is 3 and -1, right? So there we go. All right, so what are the things, and I'm trying to get to the point here as we do this so some of you can maybe notice some shortcuts, right? We know right away where we're going to draw the middle. So if you're looking for shortcuts, I could just start right there, right? I could draw that in before I do anything. There's the middle of my graph. And then for those of you that are looking for shortcuts, well, what's the highest we go, right? We're using that amplitude. So the highest we're going to go is 2 up, right? 2 up from 1 and 2 down from 1. So you notice when I look at my table, there's my maximum. My highest I go, oops, that's not my maximum. The highest I go is 3 because that's 2 up from 1. And the lowest I go, my minimum, or my peak and trough, or my maximum is -1, right? So some people kind of, when they shortcut it, they don't make the table. They just recognize, okay, that's the highest I go, that's the lowest I go. They've kind of got the pattern to sine and cos memorized, and they just use it from there. Now I'm going to stick with my tables, but if you're someone who really likes to shortcut it a bit, you can. Now we don't have to do this, but I'm going to just draw in a vertical line up at the top where my maximum is, just so when I draw this, it's really kind of nice and neat. Okay, so there's like the highest I go, right? We'd call that the peak. And here's the trough. I'm going to draw this in down here. So if you'd like to do this, you can, but this isn't a requirement. You definitely have to draw the axis in the middle, though, okay? So there's my maximum and minimum, right? The highest I go is y equal to 3, and the lowest I go is y equals to -1. And again, one more time, that's my amplitude, right? 2 units, right? From there to there, and 2 units from there to there, right? Okay, so let me erase that, and let's move on and talk about the x's. All right, so this is generally where the confusion starts to set in, because are we working with degrees or are we working with radians, right? And working with both at the same time can be a little too much, right? But I'm going to try and bounce back and forth and get you comfortable with the idea of what we're doing here. So let's identify what d is first. Remember, it's x minus d. So in this case, d is, I'll just kind of squeeze this in here. Oh, you know what? We should start with k. My bad. Let's start with k first. Of course, I'm jumping ahead. We got to deal with our stretches first, right? So let's deal with what k is. K is 3 in this case. Okay, so that means we're going to be multiplying all our x coordinates by 1/3, right? Because it's 1 over k. So 1/3 times my x coordinates, right? All right, so here's the question. Do we want to work with degrees or do we want to work with radians? Obviously, the degrees are a little easier. 0, 90, 180, we can just divide those all by 3, right? And write down what we get. So I'm going to write them both, though. So I'm doing degrees here, right? 0, 90 times 1/3 is 30. 180 times is 60, right? And so on and so forth. 270 divided by 3 is 90. The nice thing, there's a pattern to this, right? As soon as you notice the distance between the first two, that's the distance between each of them. Look at 0, 30, 60, 90. What are we going by here? We're going by 30 degrees each time, right? 360 divided by is 120. There we go. I've got everything squished in there. Sorry, I'm making a little bit of a mess. All right, so there we go. So what we're counting by is, if we're doing degrees, is 30 degrees each time. Right now, how much was that on our scale, right? Remember, what was this? This was 90 here, right? Remember I said every square is going to be 30 degrees. So 30, 60, 90, so on and so forth. 180 would be a pi. So remember how you can convert if you need to, times it by pi over 180, right? Or sorry, 180 over pi. All right, so we're going by 30 degrees each time, right? Now, if we want to do the radian measurement, we can just, again, we're going to divide everything by 3. 0 divided by 3 is 0. Pi over 2 divided by 3 is pi over 6. Now, if you're like, wait, how is that, right? Or times 1/3, right? Pi over 2 times 1/3 would be pi over 6. So that's how I got that number there. Okay, so all I'm doing is just multiplying the denominator by 3, right? I got pi over 3. I got 3 pi over 2 divided by 3 just gives me pi over 2. And then 2 pi divided by 3, right, times 1/3 is 2 pi over 3. Now, obviously, you're probably going to have an easier time working with the degree measurements, right? All right, so we've got that done. So the big thing to notice here, you don't even have to fill out the whole table for me. I don't expect you to, okay? The big thing is all you really want to focus in on is what is the change between your first 2 points. We're going by 30 degrees or pi over 6 each time, right? So that's what we said. Every one of these squares over here, or every unit on my graph is a pi over 6, right? 1 pi over 6, 2 pi over 6, 3 pi over 6, or 30 degrees. So we don't need to fill out the full table. The main thing is that we need to recognize is that we're taking, what are the steps we're taking each time, right? We're stepping, I'm going to write stepping by 30 degrees, right? Or pi over 6. Okay, so that's how much we're going to change by, because this periodic function, the sinusoidal function, it's consistent, it's the smooth wave, it follows the same pattern. So once we know the difference between the first 2 points, it's the same from 0 to 30 to 60 to 90 to 120. So generally when I'm shortcutting this and I don't want to make a table, when I'm looking at the x's, all I'm doing is basically taking 90 degrees, my first step, right, from here to here, or pi over 2. And in this case, I'm dividing it by 3. And then I know each step is going to be that same. So 90 degrees divided by 3 is 30. So every step is going to be 30 degrees, where before we were counting by 90 degrees each time, right? Or a pi over 2 each time. Okay, so that's all I'm basically figuring out. Okay, so each time I'm going to go by 30. Now, let's talk about, we got to talk about the period. So how do we get the period? So earlier on in the lesson, I talked about the period is determined from this formula, okay? So the period is 2 pi divided by k. All right, so what is k in this case? It's 3, right? So 2 pi divided by 3. That's our period, right? In radians. Now, what if you want it in degrees? Okay, so remember, the period is how long is this going to, how long is this from start to beginning? It's going to be 2 pi over 3, right? It's less than a full circle because 2 pi is a full circle. So we've taken 2 pi, a full circle, and divided it by 3. That's all we've done, right? It's a third of what it was before. In degrees, maybe it makes a little more sense. Normally, oh, sorry, my dog. 360 divided by 3, right? So what's 360 divided by 3? 120 degrees, right? Sorry, that looks like a 6, but that's 120. So that's what it would be in degrees. So again, less than a full circle. 360 is a full circle. It's a third of a full circle to do one cycle of this, one period, right? So this thing's been compressed. It's been squished down. So when we draw it, instead of this, it's going to be squishier like that, right? Maybe that's not the best example, but we'll draw it and see, right? It's been squished down. All right, so there is our period. So it's good. I want you to give it to both in degrees and radians when you do your work, okay? Provide both answers there. All right, so that we can get used to going back, and that 2 pi over 3 is 120 degrees. Okay, so we've done that. We know we're stepping, and another place you can spot that, if you did your full table, let me just point out another kind of a little important piece. This, right, notice how right there, the end right there, that is our period, right? That should match the period because our last point, right, match the period. There we go. Notice how it's the same numbers there, right? Because that's the end of one cycle. After only stretching it, right? We haven't moved it yet. We haven't translated it. So after we've stretched or compressed it, so we've compressed it, now instead of being 360 like it was up here, right, in 2 pi, now it is the newer numbers, 120 and 2 pi over 3. Okay. Now, the final piece of the puzzle is knowing where to start, okay? So we're not, because we're shifting stuff, right? So now we have to identify what D is. And that was the one I started with by accident, but we want to, here we go. Okay, so remember, D, we'd use the opposite sign there. So in this case, D is pi over 3. Or, what the heck is that in degrees, right? So if you're not a big radian fan yet, okay, so all we're going to do is times that by 180 over pi, right? So the pi's cancel out. What's 180 divided by 3, right? We end up getting 60 degrees. So we're going to move this 60 degrees over, okay? So instead of saying pi over 3, it's 60 degrees, right? So again, just that's a big part of this week, okay, is getting used to and comfortable with working with these. I know you're not pro at it yet, but just getting comfortable with using both, okay, the radian and the degree, okay? So we're going to move it 60 degrees to the right, okay? So our phase shift in this case is going to be to the right, okay, right, pi over 3 units, or 60 degrees, okay? Now again, when you get into higher level math, we really don't use degrees, we use radians. So I want you to kind of get comfortable with both, okay? I know you're more comfortable with degrees, but really work on it. Now, here's the great thing. That's gonna be the first point. That tells us where we're gonna start at. So what do I mean by that? Well, let me show you here. Let me just make a point of this here. So that right there, that 60 degrees or pi over 3, that's our starting point. Now, I'll show you in the table. How do we know that, right? How did I know that's my starting point? So again, I'm kind of showing you the shortcuts, right? Now, let's say we didn't realize that. We go to our table, we're just doing it the same way. What are we going to do? We're going to go 1/3 x. Now, we're going to either add, depending on if we're doing degrees or radians, right? If we're doing radians, we're going to add pi over 3. If we're going to do degrees, we're going to add 60. Now, I get everyone here is like, okay, so that's way easier. 0 plus 60 is 60. 30 plus 60 is 90, and then so on and so forth, right? Same thing with the radians. 0 plus pi over 3 is pi over 3, right? Well, what about the next one? What's pi over 3? Or sorry, pi over 6 plus pi over 3. So if we're going to do it in radians, right? We'll just get a common denominator. Well, that's pi over 6 plus 2 pi over 6, right? There you go, 2 pi over 6. So what do we end up with? 3 pi over 6, which reduces to pi over 2. So that's where we'd start, right? At pi over 2. Okay, so you don't have to do all that, but the point I'm trying to make now is, look, remember I said this is my starting point at 60 degrees or pi over 3? Well, look, isn't that the first point in my table? That's all I really care about. Now, if you want to keep going down the table, you can, but let me show you. Here's what I'm going to do. When I graph this thing, now I'm going to do the real graph. Okay, I'm going to do the real graph in red here. Okay, so I'm going to start at 60 degrees or pi over 3, right? So where's 60 degrees? Well, we said each one of these squares is going to be 30 on my graph, right? 30 degrees, 60 degrees, 90. So I'm going to start at 60 degrees, 2 squares over, and start at 1 right there, right? Again, this is the scale I'm going to use for everything, just so we're really consistent this week, okay? 30, 60, 90. We're going to use this scale for everything, okay? All right, so we're going to start right there. Okay, now, I don't need the rest of these. So if you're like, well, how are you going to do it without the rest of the x-coordinates? Remember we said before that we're stepping by 30 degrees. So that's 1 square each time. So pi over 6, we're just going to take a step over by 1 square, and then we're going to go to the next point, right, which is 3. When I already wrote down the first point, or second point here, which is 90, right? 90 over 3 up. Well, the next point is going to be 1 square over again, and at 1 right there. So there, where's the next point? At -1. Down here. So I'm just looking at these y coordinates over here. 1, 3, 1, -1, and then back up to 1, right? So these that's where the K and the D come in really handy for shortcutting thing. If we can just figure out what we're stepping by here, that just tells us how many squares to go over, and we find out our first point, we can just do that, start there, and just go by, in this case, 30 degrees each time. All right, so let me just try to connect the dots, and there is one period or one cycle, right? The period, again, is 120 degrees. To go from 60 to 80, right? From here to here, from 60 to 180 is 120 degrees, or 2 pi over 3. So that's one period and one cycle, right? All right, cycle. Okay, so there we go. So now let's continue this. Now what I'm going to have is, for these questions, there's a domain. This is where I want you to extend it to. So I want you to draw this thing all the way between negative pi and 2 pi. So what I'm going to do, I always like to draw on a vertical line at those two spots. So one at negative pi. And again, what is negative pi? Negative pi is just negative 180 degrees, right? We can convert that. And let's draw another line at positive 2 pi right here. Now I'm making this seem way more complex because I'm just rambling on, trying to kind of give you everything I can about it, right? But there's where we want to extend this to, okay? Between those two lines there. So my graph should be between there and there. So let's extend it. I'll use the rest of the graph in a different color here, just so we can, differentiate between the original period and then us extending it. So I'll just do the rest in blue. All right, so what am I doing? Starting at 1, then to 3, then a 1, then a negative 1, then back to 1. So I'm just going to go up and keep the pattern going. Up, down, down, up, up, down. All right, run out of room. There we go. All right, connect the dots. Make your nice smooth wave. Hopefully you can do it a little better than me. Now, really focus on a wave, not straight lines. You should not be using a ruler. I know we're not all artists, but just do the best you can. Okay? All right, take your time when you do this. Make a really neat product the best you can. All right, so I'm just continuing the pattern, but in reverse now, right? Just by looking at my original 5 points and continuing this periodic pattern. All right, up and down and up. That one was not very good. I'm just trying to hurry up so I can move on and not bore you to death. This could be a little better right here. All right, anyways, there we go. So there is the sign, right, drawn between there and with the transformations of that function. All right, so I've made it seem complex with so much extra work here, but let's do another one and just, again, try to focus on those key things, okay? Okay, our next example, we're going to graph the cosine function, right? So that's the first thing we want to identify. Are we working with sine or cosine? Those are the only two we're working with. All right, so the cosine function, I got my table ready to go here. I wrote both the radians and the degrees again. I wrote them both for you. Here's the degrees. Here's the radians. Okay, let's write out what do we got here. Y equals cos of x or cos of theta, whatever we want to start with. And let's write down this table. Now this one doesn't start at 1. It starts at 0. It starts at 1. It goes 1, 0, negative 1, 0, and back up to 1. Okay? All right, let's do the easier things first again. Let's do A and C. Those are the easy ones. So A is the value in front of our function here. So in this case, A equals negative 1. Okay, so what do we do with that? We multiply all our y coordinates by negative 1, right? So negative 1 times y. It's going to cause a reflection, right? So if it originally looked like this, which it does, right? It's going to reflect and look like this now, right? Okay, so we're going to multiply all of these coordinates up here, our y coordinates, by negative 1. So now we have negative 1, 0, positive 1, 0, negative 1. All right, now what's our amplitude? When we're asked for our amplitude, okay, it's the absolute value of A. So in this case, our amplitude is still 1, right? So think about it. Even though we flipped it, because this is what the original would look like, right? Remember, the amplitude from here to here is 1 unit. All we did is flip it. It didn't change, right? So just because it's like this, oops, sorry, it's kind of sloppy, it's still 1 unit, right? So it didn't change other than just reflecting it. So the amplitude stays the same. All right, let's identify what C is. C is at the back, right? C is negative 2. So that tells us we're going to have a vertical displacement. We're going to move everything down 2 units, right? All right, so let's take all our y coordinates and subtract 2 from them. So negative 1 times y, let's minus 2, right? So I'm going to be at negative 3, negative 2. Sorry, where am I at? Negative 1. Oops, there we go. Negative 2, negative 3. All right, so when I make my scale, whatever you want, if you're someone who just likes to go 1, 2, 3, that's fine. It just gets really squishy, so I like to stretch it out a little bit. So I'm going to go, all right, 1. Everything's in the negatives, though, this time, eh? So I'm going to go 1, 2, 3, just to stretch it out a little. 1, -1, -2, -3. Okay. Now, where is our axis? You have to draw that in, okay? So the axis comes from our vertical displacement, right? If we moved everything down 2, remember the axis was y equals 0, but it's y equals whatever c is, so y equals -2. So we want to make sure we draw a horizontal line there at -2. All right, so there we go. That's the one line you have to draw in. You don't have to draw all these other lines in, I'm doing, but I like to. I think it makes it nice and neat and accurate. All right, so what's the highest it goes? I always like to draw that line in. There we go. There's the highest, and where's the lowest it goes? But if you feel it's just making your graph a little too messy, there's too much going on, don't feel the need to draw these lines in. I usually draw them as like a light dash line. It's just that would be a real mess if I tried to do it by hand on this computer with dash lines. So I'm just using a lighter color here. So there's y equals -1. That's my maximum, right? My peak of my sinusoidal graph. And the trough, the lowest it's going to go is -3. Okay, so my graph's between there and there. And again, those people that really start getting into shortcutting, especially in grade 12, will really talk about some other shortcut methods, or in physics. That's generally, you look at your amplitude, right? You look at your axis in the middle. My axis at -2, my amplitude's 1. So it's 1 up from -2 and 1 down from -2, right? All right, so we got those guys out of the way. Let's get into, that's the easy part. Let's get into the things that affect the x-coordinates, right? So first, let's identify what k is. K is 1/2, right? Okay, so that means we have to multiply all these x-coordinates by a half, right? Or not by a half, sorry, by 1 over k. So we're going to double them. We're going to multiply them by 2, my bad. So 2 times my x-coordinates. So that means everything's going to be twice as wide, right? Instead of 0, 90, 180, 270, 360, right? You're going to double them all. Now, you don't have to write these all out if you don't want. Generally, I just basically look at what's the distance from the first one to the next one. Well, I'm going to start at 0 degrees, and then I'm going to times 90 by 2, 180. That's the distance, right? That's how far apart each point's going to be. They're going to be 180 degrees apart because the next one, 180 times 2 is 360, right? 270 times 2 is 540. 360 times 2 is 720. Sorry, I'm really squishing these in. They don't quite match up on the side there. Let me just, I got everything too squished together here, don't I? All right, here we go, 180. Sorry, I'm going to be overwriting stuff here. 360, 540, and 720. Okay, and then you can do the same thing with the radian measurements, right? We can double them. So what's 0 times 0 is still 0, right? What's 0 times, or what's 2? Sorry, 0 times 0. 0 times 2. Pi over 2 times 2 is just pi. 3 pi over 2 is just 3 pi. 2 pi, I think I've skipped one here. Oh boy, I'm falling apart. Did I miss one? Oh, I missed 2 pi. I should have done pi times 2. There we go. 2 pi, there we go. 3 pi over 2 times 2 is 3 pi, and 2 pi times 2 is 4 pi. There we go. That should be 3 pi, come on, and 4 pi. Okay, there we go. So in other words, the step between each point is 180 degrees, or pi, right? So like, what is that? Here's 180 degrees from here to here, right? There's pi, right? From there to there. So that's how far apart each of our points are going to be. The next one's going to be another pi apart. So they're going to be really far apart now, right? All right, so there we go. Now, again, the main thing, you really only need to focus on what is the distance. I'll just kind of circle the first two. That's all you really need, right? From 0 to 180, that's all I need to know. I'm just going to take a step of 180 or pi each time. That's the main thing. All right, so now let's also talk about our period, right? The period, we want to write in both radians and degrees. It's 2 pi divided by k. So what's 2 pi divided by 2? Or divided by 1/2, sorry. I'm mixing myself up here. Divided by 1/2, right? Well, that's 2 pi times 2. So it's going to be 4 pi, right? That's what we have at the bottom of our table down here, 4 pi. So instead of being 2 pi, it's double, right? Or in radians, what's 360 divided by, let me just kind of write it down here, 360 divided by 1/2, right? Because we divide it by whatever k is 1/2, which is just 360 times 2, right? Which is going to be 720 degrees. So it's 2 circles basically, right? Instead of 1 circle, right? So look at the bottom of our table. That's what matches up, 720 or 4 pi to do one cycle, right? All right, so now let's find our phase shift. Let's be careful here. So what is D? It's the opposite sign of what we see here. So I'm just going to write over here, D equals negative 3 pi over 4. So I'm going to have to minus 3/4 pi for my x-coordinates, or we could think about this in degrees. So why don't we convert negative 3 pi over 4 into degrees by timesing it by 180 over pi. All right, so when we do that, the pi's cancel out, right? And I'm just going to go, all right, what's 180 divided by 4 times 3? Where's my pen here? There we go. 180 divided by 4, or 180 times 3, right? And then divided by 4 times by 3, either way. 3 times 180 divided by 4. All right, we get, what is that, 45 degrees times, 45 degrees times 3. So it's going to be negative 135 degrees, all right? So that is our phase shift. So it's negative. We're going to move it to the left, okay? Either 3 pi over 4 or 135 degrees, depending on whether we're talking about radians or degrees. Now remember, that's where our first point is. So we're going to have to be careful here. That's where our first point is, right there. So again, if I make my table, I'm not going to do the whole thing. If I take these x-coordinates, right, and I either minus 135 degrees from them or minus 3 pi over 4, depending on what we're talking about, all I really need is that first point. I don't even usually make the table once, again, when you get really good at this stuff, right? I just go, all right, well, 0 minus 135 is negative 135 degrees, right? Or if I'm looking at the radian measure, well, 0 minus 3 pi over 4, I'm just going to start at negative 3 pi over 4. Now, the only thing we got to be careful is, where is that on our graph? Let's think here. We're actually counting by 30s, right? That's negative 30. That's negative 60. That's negative 90. That's negative 120, right? And this would be negative 50. So I've set my table up. Doesn't work quite as well with radian measurements, or with quarter measurements here. But let's think here. Isn't 135, couldn't I just break that up into 120, right, plus 15? So in other words, 120, well, we have that, right? 30, we're counting by 30s, right? 30, 60, 90, 120. So that's 4 squares, right? Based on again, the scale I'm using, right? That's 4 squares, and 15 is just half a square, right? So we're just going to go back 4.5 squares, okay? So everything, when you're doing these quarter measurements, like 3 pi over 4 or whatever over 4, that's when you're going to land on the half. So this is a little trickier. So let's go back, and that's where our first point's going to be. It's going to be 4.5 squares back. So it's going to be right 1, 2, 3, 4.5, somewhere right here. That's where negative 135 degrees would be, right? Because that's 120 plus 15 more, half a square. Because every square on this graph is 30 degrees. So make sure you make note of that, or else, yeah, it gets confusing. Just, again, on the scale I'm using, right, 1 unit on the x-axis is 30 degrees. Okay, so 15 degrees would be half a unit. So those are the trickiest ones, but there won't be any third units or anything goofy like that, okay? So if it's a quarter, you might be landing on that. Okay, so there we go. So let's start graphing this thing. All right, so let me just get rid of all this junk here. All right, so we are going to go negative 135 degrees, which is 30, 60, 90, 120, and a half brings us to 135, and we're going to start down here at negative 3. So we're right on the half. We're halfway in between. Oops, right there. Okay, so there's my first one. Now, what are we going to count over? Well, we can, if you want to figure out the next one, you can, right? You can go, well, what's negative 135, right? What's 180, right? I can figure out the next one by taking this guy right here. What is 180 in my table, right? Minus 135. So 180 minus 135 is 45 degrees. You can do it that way and just figure out where 45 degrees is. So 45 would be 30 plus 15, right? 1.5 squares. Right, so I go over 1.5 and go down to 2, right there. Or didn't we just say that we are counting? Remember our scale? So that's, again, what's our scale here? We are counting by 180s each time, right? So our scale right here, oops, right? That tells us we're counting. That's what we're stepping by, right? We're stepping by 180. Well, how many squares is 180, right? If you look at the original scale, how many squares is that? 1, 2, 3, 4, 5, 6. From 0 to pi, or 0 to 180. That's 6 steps. So all I got to do is just count over 6 steps. So notice from here to here, I'm on the half. 1, 2, 3, 4, 5, 6. Notice I ended up at 45 degrees right there, right? So let's count 6 more, right? 1, 2, 3, 4, 5, 6 on the half. And my next one's, oops, up here, right there. So again, I counted 1, 2, 3, 4, 5, 6 steps. We're just always on the half, right? Where's the next one at? 1, 2, 3, 4, 5, 6 right there. And the next one's at 1, 2, 3, 4, 5, 6 right there. Okay, so there it is. Now we just gotta connect the dots without using, remember we flip this thing, right? So, and don't use straight lines here. Oops, I keep going underneath. All right, so it's supposed to look like that smooth wave, right? Try not to go above like I'm having trouble with my pen here. I've drawn much better than this. There we go. Okay, so there it is. There's one period of this thing, right? One period is 4 pi, right? One cycle, one period. Because we said it's cycle. There we go. Right, it's 4 pi, so it's gotten a lot longer, right? We've stretched it out. It's 4 pi right up here, or 720 degrees, right, from beginning to end. All right, so I didn't even finish my table, right? What did I do one last time, right? This is my starting point right here. Find the starting point, right? And then use what you're stepping by here. I'm stepping by 180. So look at our scale. Again, what is 180? If this is 0 and this is 180, which is pi, I count the squares. 1, 2, 3, 4, 5, 6 steps. So every time I find my next point, starting from here, the first point, I just count over 1, 2, 3, 4, 5, 6 steps. Okay? And that's how I can find more. All right, so now, what does it say for the domain? What does it want us to draw? It says the domain, draw this thing between negative 2 pi and positive 4 pi. All right, so I'm just going to draw in a vertical line at 4 pi. Here we go, and draw in a vertical line just so I do a neat job here. Sorry. Oh boy. There we go. And let's draw another one in at negative 2 pi. So always check the domain. Each question I kind of give you a different domain and range to draw it between. All right, there we go. Okay, now let's continue it. I'll do it in a different color. So I'll start by going backwards first. So I'm going to go back 6 steps. Remember, I'm always halfway in between a line. So 1, 2, 3, 4, 5, 6. And we're going to come back up, right? Oops. Come on there. Now, obviously the next point is going to be over here somewhere past our line, but it would basically look like this. So you just kind of continue what it would kind of look like, which is that, right? Because the next one's 6 steps over, like 1, 2, 3, 4, 5. It's over here somewhere, right? So it's off our graph, but just draw it up to the line and then cut it off like that. Same with this. Like if I count 6 over 1, 2, 3, 4, 5, 6, that would be right here. So let me just get rid of those. That would be right here, but that's off my graph. So what I'm going to do is just draw my line, my curve, my smooth wave heading towards that, but stopping. There you go. All right, so we've drawn it. We cut it off at the 2 cutoff points like they told us. They said draw it between here, positive 4 pi, and negative 2 pi. There you go. All right, so that's the trickier one, not because it's cos, but the only reason this one is trickier is because the scale I'm using and because we're dividing it by 4, right? That's basically why, okay? So those quarter pies are a little tricky, or basically when we're counting by 45 degrees instead of counting by 30s, because our whole scale is set up to count by 30s, right? 30, 60, everything's counting by 30s. If you're counting by 45s, right, basically tell yourself this, right? If this is 90 here, let's try and simplify this as much, and this is 0 here, 45 degrees, every 45 degrees is, oh, it drives me nuts that it connects these 4s up every time, right? 45 degrees is a square and a half. So on my scale, this is something you might want to make note to yourself. On my scale, okay, 45 degrees is 1.5 units, okay? On the graphs we're using. 30 degrees is 1 unit, right? Because 15 degrees would be half a unit, so 30 plus 15 is 45. So in this case, that's basically what we were counting by, was using on the 45s, right? All right. Maybe I'll do one more. If you're burnt out and don't want to watch anymore, that's fine. I think I'm just going to do one more. I know this video is way too long. You know what? Actually, I won't. I'll just give you a few to try this week, okay? And give them a go. And if you want to ask questions on Edsby, and I'll answer them the best I can.